Hi, this video is for Chapter 9 to introduce you to some of the confusing language and variables that make up confidence intervals for estimating the population proportion and the population mean. Okay, so Chapter 9 is the introduction to language that we're going to see continue when we get into hypothesis testing. And so it's pretty important to be clear on what we're talking about here. So N, whether we're talking about a population proportion, whether we're talking about estimating a population proportion or estimating a population mean, N is the sample size. So whenever we're talking about looking at a sample, so a portion of our population, a sample, we're talking about statistics. And if we're talking about the population, we're talking about a parameter. So N is our sample size for our sample of the population we're looking at. E is our margin of error when we're looking at confidence intervals. So what does that mean exactly? So if we're estimating a population proportion, so that means we're trying to figure out, let's say out of the whole country, when they talk about elections and what proportion of people vote for one of the candidates. And so let's say 5% of the general population votes for an independent candidate. So that would be our population proportion, with the parameter, that would be 5%. But we don't ask every single person, voting age person in the population, whether or not they would support an independent candidate. Instead, we take a sample of people and figure out from that sample what the proportion is. So N is the size of our sample, and X would be the number of people that said that they would vote for an independent candidate. And so we end up with this P hat, which is our point estimate for our population proportion. So that's basically our sample proportion, and we're going to use it to estimate what our population proportion is. And so the way we do that is we create a confidence interval. And so the confidence interval, say we want to be 90% confident that our population proportion falls within a specific range. So that's what our confidence interval is. It's the range that we're talking about. And so the width of the range is 2E, where E is our margin of error. So if we said 5, so maybe the general population was 5% for it, and we're trying to estimate it based on our sample. And so maybe our sample, our point estimate was actually different, like 10%. Well, we're going to create a margin of error for it, and we're going to say we are pretty confident, 90% confident, whatever we decide, that the population proportion is going to be somewhere in this range. So E, the margin of error, is calculated by finding the critical value and then calculating the estimated standard error. So the estimated standard error for this point estimate of the population proportion is the square root of P hat times 1 minus P hat over N. And to find the critical value, so it's a little bit confusing because sometimes critical value is a Z and sometimes it is a T, and I will explain that in a minute. But the critical value you find using software or a table. I recommend software, where what we're doing is we're trying to find the position on the x-axis for the Z. This is a standard normal curve where this position corresponds to this area. So if we're looking for the critical value with 10% of the area to the right of it, then this would be 0.1. So that's the critical value number, and you use that and this calculation to calculate the margin of error. So the way the confidence interval works is the upper bound of the confidence interval. We take our point estimate, the P hat, and we add the margin of error to it. And then to find the lower bound of our confidence interval, we take our P hat and we subtract the margin of error from it. So It's we say point estimate plus or minus the margin of error. Now, sometimes we are asked to relate the margin of error to the sample size. And so it's a little bit confusing in here, but basically E and N are in this equation here. And a lot of times we look at it actually as a proportion, different than these proportions. So so many words that mean different things. So E, proportional to 1 over the square root of N, or we'd say, you can also write it, N is proportional to 1 over E squared. So proportional means that these are basically equal with some constant number that can be used. Okay, so this, how E, the margin of error and the sample size are related, are useful for something like this. So this is a question from the homework. By how many times does the sample size have to be increased to decrease the margin of error by a factor of 1/9? So basically, if I'm saying I'm going to replace E by 1/9 E, and I want to figure out what that does to it, so instead of E, I'm going to have 1/9 E. What happens to my N? So instead of E squared here, my N, instead of being proportional to 1 over E squared, is going to be N is proportional to 1 over 1/9 squared times E squared. So 1/9 squared is 1 over 81, but it's 1 over 81 is what N is. So it's basically saying that if I have N, if I have 81 times N, that's going to be the same as 1 over 1/9 squared E1. So this is basically 9 squared N is going to be 1 over 1/9 squared E to the first. So that's how that works. And so for this problem, when it says how many times does the sample size have to be increased, it has to be increased this number square. Well, so the bottom of the fraction here squared. So the answer for this one is 81. Okay, so that's how those two are related. And this is how things work for population proportions now for estimating a population proportion. So estimating a population mean, this margin of error and sample size, actually this relationship is the same. So this relationship works for estimating population proportions or estimating population means. If we want to have a smaller margin of error, so factor of 1/9 means I would make this smaller. So if I have a smaller margin of error, I need way more samples. I need a much larger sample, I'm sorry. Okay, so let's look at the population mean, estimating the population mean. It's actually a very similar curve. Instead of the standard normal curve, it's called the student's t distribution, which looks very similar to the standard normal curve, but not quite exactly the same. And so when you're looking for the critical value, for estimating a population mean, instead of using the standard normal, if we don't know the population standard deviation, we have to use the student's t distribution, and our critical value, instead of being z sub c, is t sub c. So our margin of error is it's still the critical value, just like it was up here. So it's just a different critical value. Instead of z, it's t. And then this fraction here is still our standard error. just like this is the sigma sub p hat was our standard error for the population. This for the proportion, the s over square root of n is our standard error for this sample mean. So so they're the same, but the formulas are different. So you have to pay attention to that. And so X bar is our sample mean. So and so that's our point estimate. So again, all these words with different variables and different meanings, depending on whether we're talking about a proportion or a mean. So when we're talking about a population mean, when we talk about a point estimate, then we're talking about X bar. Whereas if we're talking about a population proportion, then our point estimate is p hat. So similarly, our critical value when we're talking about our population proportion is our z, and our critical value when we're dealing with the student's t-distribution is t. But the confidence interval picture looks the same, but instead of p hat in the middle, our point estimate is X bar. And so this is saying that we think that the population mean is going to be somewhere in this confidence interval, plus where it's the sample mean plus or minus a margin of error. And sometimes we're given the margin of error and we're asked to find something else. And so if we're given the margin of error, like one of the problems says within 3, well, then what they're saying there is E equals 3. So sometimes they give you the value of the margin of error, and then you have to use technology like StatCrunch to calculate the sample size. Okay, that was very long, and I hope it helped.